Alright, so in this video I will be getting into another form of market failure that we'll be discussing in this particular course. Market failures become very important because historically speaking, microeconomics was a discipline that really believed heavily in the concept of free markets. And as we've learned in class so far, in order for free markets to work in an optimal fashion, we require them to have a number of assumptions. Now, anytime you make an assumption in an economic model, what you necessarily are doing are stripping away reality. You're taking away the complexities of real life, which oftentimes cause the model or the math behind the model to really become very complicated. And you'll see at the end of this video, I take you through a numerical example of a particular problem that even some small relaxation of assumptions causes the complexity of the model to go way up. So let's get started. We have thus far in the course repeatedly referred to the first fundamental welfare theorem. This was developed by the economist Arthur Pergot, who was trying to generate a basic guiding philosophy to how economists thought about markets. Now again, historically speaking, microeconomics believed heavily in freely competitive markets to the extent that, in fact, the first fundamental welfare theorem says that freely competitive markets should maximize economic efficiency. Now, we've already discussed two separate situations in which the first fundamental welfare theorem is not rejected, but is intervened upon by governmental policy. Price controls, floors or ceilings, and also the uses of taxes and subsidies are interventions which take away the freely assumption that we make for the first fundamental welfare theorem. Those markets are no longer free because the government has intervened in their outcomes. Also, we've discussed externalities and also public goods as well. These are types of products that cause us to reject the first fundamental welfare theorem because those theories are based on the idea that social value is perhaps more important than economic value. So while markets still maximize economic efficiency, under externalities, the idea is that they do not maximize social efficiency. Otherwise, if we're not dealing with a market with price controls, taxes, and subsidies, or externalities or public goods, we have four main assumptions that we have that would cause the first fundamental welfare theorem to in fact hold. The many buyers, many sellers assumption. This essentially means that no one buyer and no one seller has the ability to affect the market. Really, that means affect the price. Free entry and exit. This means that buyers and sellers are able to get in and out of the market freely. We're going to assume that whatever good we're talking about, we're going to homogenize it, meaning that if we're talking about the market for apples, as I've said, every apple is identical. This prevents the concept of brand loyalty. We'll discuss brand loyalty later in the class when we talk about market power. And the important one for this particular video is perfect information. Typically what we mean by perfect information is that the quality and the process by which the product is both conceived as well as demanded is known to all parties. So consumers understand what they're buying completely, and producers understand the demand for their product completely as well, because they see consumers reveal it in the form of market behavior. What we're going to do in this video is we're going to say what happens if we relax the perfect information assumption. Again, under the first fundamental welfare theorem, we generally believe that free markets are preferred because, again, they maximize economic efficiency. Now, of course, even in the context of where we believe we have free markets, in other words, where those assumptions are all met, there is some conversation about one of the things that the first fundamental welfare theorem ignores is something like inequality, but that's for another video. But if we do relax our assumptions of free markets, of competitive markets, we get some interesting results. So let's consider a classic situation in which we have what we're going to refer to as an information asymmetry. And this situation is someone looking to buy a used car. This is a classic economic problem, and one that everyone is well aware is rife with potential pitfalls. But let's talk about. So what we're going to do is we're going to hold two of the four assumptions, but then we're going to relax two of them. And the two that we're specifically going to relax are homogeneous goods and the perfect information assumption. And specifically what we're going to assume is that there are more than one type of good, so therefore we relax the homogeneous goods assumption. And then what we're going to show is that what happens when the consumer maybe doesn't know what type of good that they could potentially purchase. So here's a scenario. Clementine's looking to buy a used car, which we'll assume can either be a peach, which means it's good quality and has a high price, or a lemon, which means it's bad quality and has a low price. Owners of for sale used cars have all the information about their cars, how the car was treated, what the car has gone through, any peculiarities that may exist with the car. Buyers of used cars, however, lack this information and can only estimate the quality of a used car. And in fact, this is quite representative of what occurs when someone buys a used car. I personally have bought many used cars. In fact, every car that I've ever purchased has been a used car. And every time that I've done so, there has been some level of consternation or angst that accompanies this decision, because there's always that potential in the back of your mind that what you think is a good car may in fact turn out to be a lemon. We're further going to assume that peaches are worth $1,000 and lemons are worth $500. Now, in economics, the concept of worth is very important, and here we mean it quite literally. This is to say that if I were to buy a car and then I wanted to turn around and sell it, if it was a peach, I could expect to get $1,000 for it, and if it was a lemon, I could expect to get $500 for it, assuming that people knew what peaches and lemons happened to be. Further, we're actually going to specifically assume that peaches exist with probability 0.75 or 75% or 3 and 4, and that lemons exist with probability 0.25 or 25% or 1 and 4. What this means is that for any given 4 used vehicles that may be on the market, we're going to assume that on average 3 of them are peaches and worth $1,000, and 1 of them is a lemon and only worth $500. Let's take a step back for a moment and consider a classic physics problem known as the Schrodinger's cat. Schrodinger's cat was a concept that was developed by the physicist Arthur Schrodinger, in which he was trying to understand the concept of time-space. What Arthur Schrodinger realized was that if we think about the future as a fixed point in time, we are likely missing a very real complexity, and that is that once we start thinking about the future from any given point in time, the actual outcomes we may experience may be in fact varied. Consider the extreme example of when I cross the street. If I don't look and I don't see whether a car is coming and I just walk across the street, there's some probability that I'll get hit by a car and some probability that I won't get hit by a car. And the levels of those probabilities are affected by whether I choose to look both ways. So in other words, when I'm thinking about when I cross the street and I'm considering the 2 potential outcomes, one outcome when I'm hit by a car, another outcome when I'm not, I need to consider both of those potentialities. And of course, I try to maximize the probability that I'm not hit by a car. In other words, I try to maximize the probability of the good outcome. Now, what Schrodinger posited was that we put a cat into a box that we cannot see inside of it. So once the cat is in the box, we are not able to see the behavior of the cat. Also inside of the box is a poison vial, with a random release hammer. So at one point, the hammer may release and may break the vial of poison. If the vial of poison is broken, the cat will die. If the vial of poison is not broken, however, then the cat will not die. Now, what Schrodinger pointed out was that until we look into the box, until we look and open the box up, we have no idea whether the cat is alive or dead. And so this presents an interesting time-space question, which is, before we open the box, is the cat both alive and dead? Well, this is certainly something that Schrodinger was very interested in, and he said yes. In fact, before we have the information that specifically tells us, the data that specifically tells us whether the cat is alive or dead, we, in fact, would be missing out on at least one of the possibilities by assuming one way or the other. So instead of assuming the cat is either alive or dead, I wonder if the cat is alive and or dead. Now, let's go back to our previous problem. This recalls the concept of expected value, which we discussed previously in class. The idea of expected value is that I can consider the value of something that has an unexpected outcome. For example, the expected value formula for a 2-outcome potential would simply be the probability of outcome A times the value of outcome A plus the probability of outcome B times the value of outcome B. So simply we take the probability that something occurs, we multiply it by the value of that occurrence, and then we do this for every potential outcome. And when we add up all the values multiplied by the probabilities, it gives us what we can expect to get. Now this can be a little confusing for students, of course, because in one-off situations, we will only ever see one outcome. Like for example, with the lottery, I play the lottery, I buy a lottery ticket, and then I either win or I don't. So this situation of considering what happens if I either win or don't win simultaneously can be a bit confusing. But in our particular example, what we're implying is simply that because the probability of a peach is 75% and the value of a peach is 1,000, and the probability of a lemon is 25%, while the value of a lemon is $500, that this implies that the expected value of a used car, of any used car, is $850. Now, what we mean by expected value is simply that if I were to play this game an infinite number of times, then I would expect on average for the resulting price of a car to be $850. That if I took every peach out there and every lemon out there and I computed the average price of cars from that entire sample of cars, that the resulting price would be $850. So it comes from this idea of, imagine playing a lottery an infinite number of times, like a very simple lottery, like this one, where I flip a heads or tails coin. We call that a fair coin. Heads, I pay $1. Tails, I receive $1. Very simple game. So the EV of this game is, of course, 0, because the probability of a heads is 50% and the probability of a tails is also 50%. And so basically the payoffs counteract each other, and so my expected value is 0. Now, of course, if I only play this game once, I'm only going to see one of the outcomes. I'm either going to have to pay $1 or I'm going to receive $1. I'm never actually going to pay or receive $0. But if I play this game an infinite number of times, I can expect at the end of that infinite number of play periods to have exactly $0. Or in essence, all of my wins are going to be counteracted exactly by all of my losses. So let's go back to the lemons problem. The problem is that the expected value is $850. And so let's think about this for a moment. If the expected value of a used car is $850, and of course this is known to Clementine, we're going to assume that Clementine knows the probabilities and that she knows the values of cars. She just doesn't know which car is a lemon or which car is a peach. Then this implies that Clementine will assess the value of the vehicle to be $850. But at an offered price of $850, the only owners that would be willing to sell their car for that price would in fact be the owners of lemons, because the owners of peaches know that their car are peaches, and further, they know that peaches are worth $1,000. So therefore, if Clementine were to offer a owner of a used car $850, which is her expected value for the vehicle, and the owner accepts that deal, Clementine is very, very concerned, of course, that she may in fact have just purchased a lemon. So essentially what Clementine does is she makes the following thought experiment. Well, if anybody who would accept my offer must be selling a lemon, then I can only assume that any offer I receive at $850 that is accepted would therefore be a lemon. So what this means, in fact, is that the only cars out there that would be sold for $850 would in fact all be lemons. And so ultimately Clementine would be so concerned that she could ultimately buy a lemon that she doesn't buy any cars at all. In fact, the particular economist who came up with this idea, George Akerlof, in fact, we call this the Akerlof's lemons problem. He posited that if this problem was extreme enough, in fact, that the entire market would unravel, and that ultimately Clementine would never purchase a vehicle, which is problematic because Clementine wants to buy a vehicle. She is in the market for a used car, and used cars are available for sale. So economic efficiency would say that since there's a demand for a car and since there is supply for the car, then an efficient market would be able to supply that car to the consumer. But because of risk and because of the information asymmetry inherent in the used car market. This is why so many used cars go unsold. And in fact, historically, the used car market was as inefficient as Akerlof had feared. There's also another problem that's a little bit more indirect. Clementine's lack of information, again, what we refer to as an information asymmetry, creates risk. The risk arises because there's doubt in the outcome. It is not certain. In other words, the car may be a peach or it may be a lemon. Now, there's this concept in economics called relative risk aversion. And the idea is that we all have our own relative risk aversion. Some of us are risk-loving, which mean that, in fact, risk increases our utility. People who are addicted to gambling or thrill seekers, like people who jump out of airplanes, we may readily classify them as risk-loving, where, in fact, the risk of death or the risk of losing money, in fact, seems to be the root utility-maximizing behavior in which they undertake. Risk-neutral implies that risk imparts no increase or decrease in utility, so no utility or no disutility. We may consider that casual gamblers, people who are able to walk away from the tables, potentially before they lose a lot of money, they are probably risk neutral. The risk doesn't cause them to want to gamble more. They're gambling more just because they have the potential of winning money, not because they're experiencing risk. Now, the vast majority of us are what we refer to as risk averse, meaning that risk is something that greatly reduces our utility. In fact, what we'll talk about here in a moment is the idea that when there is risk, oftentimes we will require compensation in order to overcome that particular risk. And so, of course, the higher your relative risk aversion, the higher compensation you're going to be willing to require in order to incur a particular transaction. So if we go back to Clementine's problem with potentially buying a lemon, depending upon how risky Clementine tends to behave, she may, in fact, require some additional requirements from the sellers before she's willing to purchase. For example, she may require a test drive, or she may require the ability to take the car to a mechanic. These are, of course, ways that she can reduce the information asymmetry and thereby reduce the risk. So basically, we would say is that folks who are risk-loving or risk-neutral, they may be much more willing to buy a used car because the risk of lemon doesn't hurt their utility very much. But for most people, risk aversion causes them to not want to potentially see that bad outcome, and therefore greatly reduces their chances of actually transacting. And again, this is problematic because we want to unite consumers of used cars with sellers of used cars. But in this particular situation, the risk can get in the way of that particular transaction.